The lesson I'm teaching today is an 8th grade math lesson based on intersecting lines and how to find the point of intersection using substitution. This addresses standards 7 and 8. And so I would teach this after they learned standard 6, which standard 6 was like finding the slope and slope intercept form and like the equation of a line. So the session would kind of tie that into intersecting lines, and there'd be a little review as well as connecting it to the new material. I'd start off engage by connecting like a graph to like a map and a point on a map, and again reviewing. It would start off with a little review of like what slope is, the equation of a line, and everything, and then I would give them a problem with two linear equations, and they would be doing a think pair share. I'd give them some time, and then they'd explain their answer to the class, and that would be the engage. And then for explore, it would be a lesson. The basis of the lesson is basically like, so the teacher gets a call from the sheriff that there was a thief and that they're trying to locate the thief. So they'd all be given like a graph like this with the map of Yucaipa. And I'm in Yucaipa right now. That's why it's the map of Yucaipa. So it kind of relates to their lives. And I'd pair them up into 4 groups of 5. And there would be 4 clues, like stations around the classroom, which each group would go to, and they'd get like 7 minutes to solve it. And each clue they get like closer to finding the location of the thief. And then for the last clue number 5, I'd gather them all back in their seats, still in their groups, and they would solve the question. And then for explain, I would choose one person from each group to explain their steps and to the class. And then for evaluate, it would be an exit ticket before that they'd turn in before they left the class. And then for extend, it would be they design their own map on a graph, and each point or like landmark they choose, they would have to write the equations of two intersecting lines to come up with the point that they did on the map. So I taught this lesson with my sister, and so in the normal lesson, if I had a class, I would give them 7 minutes for each like station. But since it was just like my sister and she solved it, I only gave her as long as she solved the question. Then we moved on. So this lesson would usually be longer than just like the 20 or 30 minutes that it took to film right now. And then I had to film this in my niece and nephew's playroom. So excuse all the toys and the frozen whiteboard I had to write on. Thanks. Moving on to our next activity, I'm going to number you guys off into 4 groups of 5. Okay. 1, 2, 3, 4, 5. 1, 2. Yes. All right. All right. Oh, hold on. I'm getting a phone call. Yeah? We're on the job. Okay. So that was the sheriff's department, and we got a call that a whole bunch of hand sanitizer was just stolen from our local Vaughn store, and he needs our class to solve it. So in your groups, each person is going to get this worksheet. And if you look around the class, there are 1, 2, 3, 4 clues. So each group is going to start off at 1 clue, and I'm going to time you guys. You're going to get 7 minutes at each station. After that 7 minutes up, we're going to rotate. After we get through all of the clues, we're all going to come back, and I'm going to have one final clue to locate the thief. And so then we're going to see which groups can locate the thief. Any questions?
No.
All right, okay, so pass them back. All right, groups, 7 minutes at each 7 minutes at each station, and time starts now.
Can you write on the worksheet?
Yes, you can. Okay, so not a race. Find the equation of a line that passes through bonds and has a slope of 4/3. Okay, group 3. Elena. So, what was your first step?
I did the slope intercept form, so I did y equals 4/3 x plus b. Then I knew the coordinates for bonds was 3 and 3, so I plugged that in.
Alright, so you plugged it into this equation?
Yes.
Okay, so what does this equation look like then?
3 equals 4/3 times 3 plus b.
Alright, and then our next step is what?
Then 3 equals 4 plus b. Then you subtract 4 from, and that'll be b equals -1.
-1. Alright, so then what would our equation be?
Y equals 4/3 x minus 1.
-1. Very good. Did anyone get a different answer? And did anyone solve it a different way? Oh, Timmy, again. Great. Okay, so Timmy, how did you solve it? Okay, so you remembered from last week, we were given point slope form. And so we have this. So what are we gonna plug in for this one? So we have y minus
3
equals, what was our m?
4/3.
And what was our x1?
3.
And so let's distribute it. What does the right side become?
4/3 x minus 1. Minus 4.
Very good. And then we want to get y by ourselves to get it into slope intercept form.
So you add 3 to both sides. 4/3 x minus 1.
-1. Very good. And as you see, they both equal each other. So very good job, Timmy. Good job, Elena. Okay, and our next clue, number 4. Okay, last clue number 4. Find the equation of a line that has a slope of 1/3 and passes through in and out. Alright, so group 4. Zena, what was your first step to solve this equation?
I did point slope.
Okay, so what's the equation for point slope?
Y minus y1 equals m parentheses x minus x1.
Alright, and so what was our m?
1/3.
And what is our x1 and our y1 that we're going to plug in?
Wait, where were we going?
We were going to in and out.
Oh. Y minus -2 equals 1/3 x minus 6.
Alright, so when we multiply it out, you get
1/3 x minus 2.
And we want to get y by ourselves.
Add to both sides. Y equals 1/3 x minus 4.
Very good. Right, did everyone get that answer? Good job. Good job, class. Okay, a final clue to solve. Okay, clue number 5, which was given on the board. The thief is at the intersection of the lines from clue 4 and clue 5. Where is the thief? Okay, so Vena, can you remind us what our line for clue number 3 was?
It was 1/3 x minus 4. No, 4/3 x minus 1.
Alright, and then can the student Remind me what the line for clue number 4 was.
1/3 x minus 4.
Alright, and so this student. So what would our first step to be to find the point of intersection of these lines?
Put them equal to each other.
Equal to each other. And how do we know that they're equal to each other? What are they both equal?
Y.
And so since they both equal y, what can we say about them?
They're equal to each other.
Good job. Alright, and so then what is our next step going to be? This student.
Add 1
Add
to
1.
both sides.
Alright, so then what equation would we get after?
4/3 x equals 1/3 x minus 3.
Okay, and then next.
You subtract 1/3 x to both sides.
So then what would we get on the left side?
3/3 x equals -3. And 3/3 equals 1, so x equals -3.
Great, okay, so now we have our x, so how are we going to find our y coordinate?
Plug it in.
And which one do you want to plug into?
4/3 x minus 1.
And does it matter which one we plug it into?
Nope.
Are we going to get the same answer?
Yes.
And why are we going to get the same answer?
Because they're equal to each other.
Because they're equal to each other. And what was our x?
-3.
Alright, so let's simplify. So what do we get?
Y equals
What is 4/3 times -3?
-4 minus 1.
And so we get?
Y equals -5.
And so what is our coordinate?
-3, -5.
And so where did we find the thief at?
Chevron.
Chevron. Down the boulevard at Chevron. Good job, class. We found the thief and justice prevails this time.